third video in our series about normal distributions is finding values of normal variables. So let's get stuck straight into it. Find A if the probability of Z is between 0 and A. So Z is a normal distribution, or refers to it, it's a normal variable. So let's draw the situation here. So we should always sketch these things, and being a normal distribution, we have the mean equals 0, standard deviation equals 1. So the value is from 0 out to A somewhere above 0. We have a probability of 0.18. So the area we want is, or the area not we want, actually we've got this area. This area refers to 0.18 refers to the yellow area here. So if we use a thing on the a functionality on our calculators called inverse normal, it works in a cumulative fashion. It will find all of this area just cumulative like the other functions we've seen. So what it would give us is something that's 0.5 bigger than what we want. It'll give us something that's 0.5 plus the 0.18, which is 0.68. So if we set the inverse normal to 0.68, we'll get what we want. So we need to go inverse norm, I think that's the way it's prefixed. So let's see, we've got probability distributions and inverse normal there. You can see number 3. And we've got our area of 0.68, and it's a standard distribution, so mu is 0 and sigma is 1. And we get 0.4677. So returning back to our working, we put in our parameters and then the value of Z, which is that upper limit, 4677. So A would be 0.4677. So last example here, we have to find A such that Z is greater than A, giving an area of 0.4308. Okay, so I've got a little sketch in there, but just remember that we have the cumulative nature of the inverse norm, the CDF functions. So really, it's going to come from that direction there. So what we should do is go 1, use the complementary idea, 1 minus 0.4308, and doing that we get 0.5692. So that gives us the complementary area here. Now we simply use that in our inverse norm. So we go inverse norm in our calculator, and using the parameters 0.5692. It's a standard normal, this one, 0 and 1, and we get 0.1743, or 0.174 if we go to 3 decimal places.